Hello students, welcome to Shri classes. We'll begin with a new chapter in mathematics, chapter number 10, circles, lecture number 1. See, on the top row, couple of diagrams have been drawn. What does that indicate? We'll try to see. Here, this is a circle with center be mentioned karenge. That is preferable. O. This is also O here, and a circle with center O. All these three circles have been drawn. See, PQ is a line. This is the circle. Here, the line is a non-intersecting line with respect to circle. Here, again PQ is a line, and this line is intersecting this circle at 2 points A and B. So A and B are the points of intersections between the line PQ and the given circle. In this case, the same line, when it intersects the circle at 2 points, this particular line PQ is called a secant. समझ में आ रहा है आपको? So this is called a secant. So what is a secant? A line that intersects the circles at 2 points is called a secant. A and B are the points of intersections. What is AB in this case? AB is a chord. That means the secant PQ has a corresponding chord called AB. AB is a chord and PQ is a secant. Look at this diagram. Line PQ is intersecting this circle at only one point, that is at point A. In this case, when a line intersects the circle at only one point, the line is called tangent to a circle, and hence here PQ is a tangent, and point A, where the point of intersection takes place, is called the point of contact. PQ is a tangent and A is a point of contact between the circle and the tangent. So this terminology is very important, that is a tangent and a point of contact. So can we say now that tangent is a special case of a secant where the two end points of the corresponding chord meet or merge? समझ में नहीं आया ना आपको? See here, PQ is a secant and A and B are the two end points of the corresponding chord AB. So when A and B merge together to a single point A, then we say a tangent is a special case of secant where the two end points of the corresponding chord merge, and therefore PQ is a tangent, A is a point of contact. How many tangents can you be able to draw through a point? Let us try one experiment. Let's see here how many tangents can be drawn through one point. So let's see here. This is 1 point. Is it a tangent? No, it's not a tangent, it's a secant. Is it a tangent? Yes, it is a tangent here. Is it a tangent? No, it is a secant. Is it a tangent? No, it is a secant. Is it a tangent? No, it is a secant. Can you tell me how many tangents can be drawn to a circle through one point on the circle? Only one tangent can be drawn. This is a tangent here. Only one tangent can be drawn to a circle at a given point of contact. That you should remember. Now you tell me totally how many tangents you can draw on the circle? Infinite. Because the circle itself, the definition itself is, infinite collection of the infinite loci of points which are at a fixed distance from a fixed point. The fixed point is called the center, the fixed distance is called the radius, and therefore you can draw infinitely n number of tangents over a circle, on a circle, but through one point only one tangent can be drawn to a circle. That you should remember, because one more question you may get. Now come to this diagram over here. Here, how many parallel tangents can we be able to draw for a particular circle? All these are parallel lines here. 1, 2, 3, 4, 5, 6. All these are parallel lines. So, are all these tangents? No. this one and this one, there are only two parallel tangents which can be drawn to a particular circle. Please remember, there are only two parallel tangents which can be drawn to a given circle. So number of parallel tangents to a circle is 2. So I hope this you have understood. Non-intersecting line, intersecting line called a secant, intersecting line to the circle at only one point is called a tangent, and the point of contact is the point of intersection between the tangent and the circle, and we can draw only one line as a tangent to a circle through one point of contact, and you can have maximum of only two parallel tangents that can be drawn to a circle. This is the basics of the secant and the tangent. I hope this is very clear. So let us see one more small introduction I would like to give here. What is the distance between a point and a line? Let us see what is the distance between a point and a line. This is off the topic. This was discussed during your 9th standard. See here, I have a line over here and there is a point here. What is the distance between this point P and a line AB? Boliye, where is the distance? Is it the distance? Is it the distance or PB is the distance? Which one? Is PQ the distance between a line and a point? Is PR the distance between a line and a point? Is PB the distance between a point and a line? What is that? And therefore you must remember the distance between the point and a given line is always the perpendicular distance, and therefore PR is the distance between point P and a given line segment AB. So I hope you understand, a distance between a point and a line is always the perpendicular distance which we are talking about. Okay. So this circles chapter has two theorems which have been given in your textbook, that is 10.1 and 10.2. लेकिन हम लोगों को थोड़ा सा ज़्यादा लिखना पड़ेगा. See, I am taking theorem 10.1 as it is, and there is going to be a converse of the theorem 10.1, and both these questions have appeared in exams. अगर चाहे आपको मैं ये बोलता हूँ, where is R.D. Sharma book here? R.D. Sharma book. See, theorems. See, I want to highlight to you this 10.1 theorem. A tangent to a circle is perpendicular to the radius through the point of contact. This theorem, the tangent at any point of a circle is perpendicular to the radius through the point of contact. This theorem has appeared 2009, 2012, 2014, 2015, 2016, 2017. So you can realize the importance of this theorem. And the converse of this theorem had appeared 2012, 2013. Also this is an NCERT sum, basically NCERT numerical, which is given at the end of the text. So I hope you must have realized by now the importance of these two theorems which you can expect definitely in exam. So let us see the first theorem here. The tangent at any point of a circle, is perpendicular to the radius through the point of contact. See, it is simple here. The meaning is very simple here. Suppose this is a circle for which at point P I have drawn one tangent. In that case, point P is the point of contact, AB is a tangent. What is that I have to prove is the radius OP is perpendicular to the tangent AB is what I need to prove. Dear students, what is that I have to prove? I have to prove that OP, the radius of this circle, is perpendicular to AB. That is the statement of this theorem. So did you understand? The tangent at any point of a circle is perpendicular to the tangent at any point to a circle is perpendicular to the radius through the point of contact. The radius through the point of contact. So आपको prove करना है OP is perpendicular to AB. So this theorem and the converse theorem has to do more with the writing part. So that is more important. Let us see. Given a circle with center O, and tangent AB at point P. Tangent AB at point P. So point P is the point of contact. To prove OP is perpendicular to AB, OP is the radius of this circle and AB is a tangent, we need to prove the radius is perpendicular to AB. Construction. Take any point Q on AB. I have chosen this point Q on this line segment AB other than point P. Join this OQ passing through R on the circle. This line segment OQ passes through a point R on the circle. I hope you are able to understand. OQ is passing through point R on the circle. So O is the center, P is the point of contact, Q is a point taken on line segment AB, and I have joined OQ that passes through R on the circle. Is this clear? Next. Proof. In triangle OPQ, OP equals OR. OP equals OR because radii of the same circle. Next, here OQ equals OR plus RQ. OR plus RQ, it is not OQ. OR plus RQ. आपको समझ में आ रहा है? OQ is OR plus RQ. So OQ equals OR plus RQ. From this statement, can I say OQ is greater than OR? Euclid's postulate. The whole is greater than the part, and therefore OQ is a whole here, whereas OR and RQ are the parts of the whole OQ. So whole is greater than the part. That means OQ must be greater than OR as well as RQ. But for me here, I require OQ greater than OR. So OQ equals OR plus RQ from this diagram, very simple. Therefore OQ is greater than OR. This OQ is greater than OR. But we know that, okay, you can write reverse also, that is OR is smaller than OQ. What is OR? OR is equal to OP. Therefore OP is smaller than OQ. That means this OP is smaller than OQ. What is the meaning of this one? I can conclude from this statement OP is smaller than OQ. Here OR is equal to OP, OP is smaller than OQ. So what I can conclude is OP is shorter than, this OP is shorter than any other line joining center to any other point on AB. Suppose if I pick up a point here, one point here, and if I join this one, in that case let us mark it as yes here. In this case definitely this OP is shorter than OS. Therefore from this statement OP is less than OQ, OP is less than OQ, इसका मतलब ये है OP is shorter than any other line segment that joins the center to a point selected on line segment AB other than P. In that case OP becomes the shortest distance between the point O and the line segment AB, and the shortest distance is always the perpendicular distance, and therefore OP is perpendicular to AB. I hope you are able to understand. So OP is the shorter than any other line joining O to any other point on the AB, and therefore OP is perpendicular to AB. What is OP? OP is the radius of the given circle. Hence the radius is perpendicular to the tangent through the point of contact. कुछ doubt? As it is उतार दो तुम्हारा notebook में. Next point. Converse theorem. What is converse here is, see, listen please. There is a circle given and one radius we have drawn. At the end of the radius one more line is drawn that is perpendicular to OP, and therefore the given information here is already this is perpendicular. आपको समझ में आ रहा है? Already this is perpendicular. So AB is a line which is perpendicular to the radius OP. That much information is given to you. You need to prove that AB is the tangent at P. That is the question, isn't it? AB is tangent at P. So, converse theorem, a line drawn through the end point of a radius and perpendicular to it is a tangent to the circle. A line drawn through the end point of the radius to a circle is tangent at that point. So we need to prove AB is tangent to OP. Let's see, given a radius OP of a circle with center O, line AB is perpendicular to OP at P. This line is perpendicular to OP at P. That is given. To prove AB is tangent to the circle at point P, we have to prove AB is a tangent. Proof. Take a point Q, this point Q, which is different from point P on the line segment AB. I have chosen one point Q other than point P on the line segment AB. Now, OP differs from this. Now, OP is perpendicular to AB. OP is perpendicular to AB given to us. Among all the line segments joining O to a point on AB, OP is the shortest. You join this one, you take any other point, you join that also. Even if I join OB and OA, then OP is the perpendicular distance and this is the shortest distance amongst all the lines which join O to any other point on the line segment. Because you know in 9th standard, the perpendicular distance is the shortest distance between a line and a line, between a point and a line segment. So, OP is perpendicular to AB. OP is perpendicular to AB given. Among all the line segments joining O to a point on AB, OP is the shortest. Yes, OP is the shortest. Implies OP is smaller than OQ. OP is smaller than OQ. Or OQ is greater than OP. Yes, OQ is greater than OP. What is the meaning of this one? It means Q lies outside the circle. So, every point on AB other than P, other than this point P, lies outside the circle. Outside the circle that point lies. Implies this shows that AB meets the circle only at point P. This AB meets this circle only at point P. Because any other point if I select, that point will be outside the circle because that will be greater than OP. Isn't it? So this shows that AB meets the circle only at point P. AB meets the circle only at point P. And therefore, AB is the tangent to the circle at point P. Because the line segment that meets the circle at only one particular point is called the tangent. And therefore, as AB meets the circle only at point P, AB is the tangent to a circle at P. So this is how we can prove the theorem over here. So I hope dear students you have understood. थोड़ा सा insight चाहिए और पूरा theoretical लिखना है इसमें. So here and all these statements may be confusing for you, but I request you to look at R.D. Sharma or R.S. Agarwal. Both of these things have been taken from R.D. Sharma for your information. Okay, so make a note of this one, and then we have another theorem 10.2, that is the second theorem, and we'll see. First you note down this one. Yes students, we'll end the lecture over here. Please note down these two theorems. In my next class, I'll be taking one more theorem and we'll start solving the numericals. Thank you very much for watching.